Welcome everyone. So today we are going to discuss mainly PYQs, few PYQs, and I want to discuss northwest corner method. This was a question appeared in, this was question 4C of 2020. Then we will take one question, decision making, question 2A of 2021. And if you observe last year's question paper, see UPSC syllabus, they have linear programming. In linear programming, you mainly study simplex, graphical method, and sensitivity analysis and shadow pricing. So far, the UPSC has not gone into integer programming, goal programming. But yes, in 2020, they asked a question from northwest corner method, and which was kind of a surprise. It is because it's part of transportation problem. So I believe that in future they might ask question like let's say something from Prisoners Dilemma, then IESDS. Now let's say somebody says where it is you can trace these things from syllabus. You can trace these things from even from linear programming or the part of let's say even from operation management. Right, in operation management, let's say this transportation problem, this also comes under your operation management. So it is very difficult to segregate quant and OM. Right, so this is our plan. What we will do? Let's just these are the notes I want to discuss. So once we have discussed northwest corner method and problem on decision making, I will try to share something about this Prisoners Dilemma and IES. So this I am believing that question like this UPSC might ask. For this we will also study some theory, and I am assuming that you have watched the previous lecture on decision making, because there is something which I would not like to repeat. So given that, let's see, move to question number, northwest corner method. What this question is, this question appeared in 2020. I will quickly write the numbers. What it says, let's say there are 4 depots, depot 1, depot 2 and depot 3, and there are 3 markets, market 1, market 2 and market 3. And they have given the cost. What you do, in a northwest corner method, there is some demand, some supply, and you try to, from one place to another place, you have to supply these things, and the costs are given. So what I mean to say, let's see, these are your 3. Okay. Here, the numbers given are 23, 21, 27, 26, 25, 15, 20, 21, 20, 21, 21, and these are your demand. This is your demand is how much? 11, 14, 14, 14, and your supply. Supply is 14, 12, 13. Right. So generally you will get question like this. And what they are asking, get initial feasible solution using northwest corner method and calculate initial cost. See, solving this problem is very simple. Let's say as you solve simplex problems or as you solve layout strategies, see, it might look like that northwest corner is a different problem. But when you think, the main tool is linear programming. And let's say, suppose what you do in simplex. Simplex, you follow some steps. For example, you take a particular row, and from that you subtract the, you apply what we call Jacobian method. And you try to identify incoming and outgoing variables. So I'm assuming the aspirant who have done simplex must be understanding what I'm trying to say. But can you realize, let's say, if you can visualize when you perform a, let's say in simplex, after making the standard form, you subtract a row from another row. This is like, doing mechanically, but what is happening logically? So what you do in simplex, let's say like this. If you have to explain a child, you are performing some steps in simplex. So what is happening? Let's say you start from this point, and you have to imagine this kind of a, this is a football, right? And which has many, you must have seen the pentagons, right? Printed on the pentagon, hexagon. So you try to move from one step to another. This step to this. So you are trying to reach the highest step. So my point is, when you perform those Jacobian or Gaussian elimination in simplex, logically what you are doing, you are trying to move from bottom to, nadir to zenith. You can call it nadir to zenith. This is what you are trying to do through your simplex method logically. Okay, now same way, in this northwest corner method, you will do some, you will follow, I will say, some strategy, some steps. See, knowing that steps is nothing, you teach these steps even to a class 5 child, they will understand because you simply, but can you visualize when you, let's say, what is happening logically? That is more important. And I understand that it is not possible for aspirant to visualize that, but try to do that. See, you will get marks if you simply calculate the minimum cost. That is fine for UPSC purpose and for your marks. But while you practice these things, try to connect mathematics and logic. If you can do that, I must say that would be an achievement. Let me tell you one more thing. Let's say students who have read portfolio theory, and they know what is efficient frontier, right? You say efficient frontier is, let's say this is your risk, standard deviation, and this is your return. Okay, so you are calling this thing efficient frontier. Efficient frontier, right? And any other stock combination, let's say other stocks are here, they are not efficient. Why they are not efficient? For example, for this particular stock, on this much amount of risk, I am getting better return if I am on let's say, if I am on efficient frontier. Can you see? This will plot here. So for the same risk, I am getting more return. So this is what. So what you are trying to do, you are trying to identify a northwest corner point. Just a minute. You are northwest corner point. Now see, why I am making this point. It is not possible for me to go into theory and explain, but this visualization comes to your mind. What is happening in the portfolio theory is not very different from what is happening in northwest corner method, and it is not very much different from what is happening in simplex. That is where your linear programming and linear programming and game theory are very much related. This can be also part of game theory. So that tool, that mathematical tool, linear programming, that is very, very important. And today I will not discuss the logic behind northwest corner method, but I took, I invested 5-6 minutes in this topic because this thought is very, very important. When you prepare for UPSC or any other examination, you must keep your mind active and try to relate the thing. Maybe after, if you will keep on studying finance and let's say linear programming, one day you will get the answer. Okay, what is happening there? The efficient frontier, the way you get efficient frontier, the logic of that method is not very much different from the logic which is being applied here, right? Now let us come to this question. The question is very clear. This is demand from three markets, and this is the depot. From depot you can supply, and supply is this and the demand is. First you will see whether it is balanced or not. Demand is equal to supply or not. So how much it is? 39. Right? What about this? This is also 39. This means it is balanced. Okay. Now what you do? You see, okay, at my first market, what is the demand? You start with the northwest corner point. Okay. To give you, why you start with the northwest corner point, this idea is not also very different from See, okay, what you study assignment problem in OM. Somebody will say, okay, why I eliminate particular rows and columns? The logic is same. In the simplex also, the logic is, when you eliminate, when you perform Gaussian elimination, the logic is same. For here it is difficult for me to trace the logic, but I hope you will do it maybe some other day, not today. Now let us allocate it. 11 you have to, 11 is the demand and supply. So first you allocate 11, right? So this becomes 0, right? So demand is fulfilled, here it becomes 3, right? Now what you will do? Now you will not take, see this is 0, so you will not take this one. Now the remaining 3 where you will put? Remaining 3, again you will choose the northwest corner point of this. What is that? This one, right? So you will put 3 here, fine. After that this is gone. This is gone. Now of the remaining, see now this is gone, this is gone. You will put your, now you will choose the northwest corner point, that is this point. So your supply is 12. So you will supply 12, this becomes 0. No, you cannot supply 12 because, see that's the mistake, because here your demand is only 14. So you will supply what? You will supply only 11. Let me just write it, 11. So it is fulfilled, this becomes 0. Here you had 1, right? This is not 0. So what you will do? Again, you will put 1 here, the remaining 13 you will put here. Okay. So now this is the way you have to from this particular depot, for example, from this particular depot to this market, you have to put whatever 11 ton or whatever the quantity is. So now this is your allocation. Now cost, how you will calculate? Cost is nothing but 11 into 23 plus 3 into 21, right? 11 into 25 plus 1 into 15. Just a minute. 1 into 15 plus, okay, what happened to this? 1 into 15 and 13 into 21, right? 13 into 21. You just check what is the answer. If I'm not mistaken, it is something 789 or something. I do not remember that. But anyway, you will do it. 879 is the 879. So this is the way you can solve it. Fine. Now let us move to another question. This is question number 21. Right. This talks about, again, this is a question of a decision making. So here, this is question number 2A of 2021. 2A of 2021, right? So the question is like this. They have given 3 states of nature and 3 alternatives. Alternatives are A1, A2 and A3. Okay, states of nature are E1, E2 and C. This is not the first time UPSC is asking a question like this. They have asked it, if I am not mistaken, even in 2019 or something. Very similar question. And before that they asked it, I think not in 16. अब देखिएगा 15 or 16 में somewhere they asked it. So these are the states of nature. States of nature. Let's say what do you mean by states of nature? Let's say interest rate. Interest rate might be stable, or it may decline, or it may increase. These might be 3 states. And if you have gone through our decision making lectures, you remember when we were solving decision tree. So there we saw after a particular nature, the demand might be high, medium, low, right? Then you take to multiply the probability with the payoffs, and here you get the value. and then you used to compare. So the same idea. So here what is given is 3 states of nature and 3 alternatives. See, this question is very simple and easy, but what I found little bit tricky in this question, generally states of nature is written on your this row side, and alternatives are written this way in most of the question. If you see 99% question, UPSC just tinkered with the layout, but again that should not be a problem. 190, 164 and 142, right? 186, 162, 144, 182, 166, 174. So first criteria is maximax. First criteria is maximax. What you do in maximax? You take the maximum of and then you make a function where you will take the maximum values, and then finally you will choose the maximum of that. So let's say in the first alternative, what you will choose? Maximum. That is out of these 3 states, which one you will choose? See, if you choose alternative 1, so you can face 3 situations. Either you can win 190, 164 or 142. So you are assuming you will get 190. See, max is being very, very optimistic. Let's say what it means. See, you might, if you choose alternative 1, your payoff might be 142, 164 or 190. But you are choosing 190. This means you are being optimistic. Fine. Similarly, from here you will choose 186, highest one, and here also highest is 182. And then you will take the maximum of that, that is 190. So this means you will choose alternative 1. This is your criteria, maximax. Then maximin. This is maximin. Here what you will do? You will take the maximum of minimum values. So what is the minimum value? Here 142, here 144, here 166. 142, 144, 166. See, the important point to note here is, generally what was happening, your minimum value was coming in state of nature 3 for alternative 1 and 2. But here the minimum value is coming for state of nature 2. So then you will take the maximum of that, which is 166. So you will choose alternative 3. Fine. Now the third criteria is Hurwitz criteria, and the degree of optimism is 0.7. Degree of optimism is 0.7. See, degree of 0.7. Pessimism कितना हो जाएगा? 1 minus 0.7, that is 0.3. Fine. Now what you will do? Simply, degree of optimism you have to multiply by the highest value. That is, so I am just writing the function. So the first value I am writing. So highest value is what? 190 for alternative 1 into 0.7 plus pessimism is what? 0.3. Right? 142 into 0.3. Fine. Similarly, 186 plus 144 into 0.3. Right. Then again 182 into 0.7 plus 0.3 into 166. 182 into 0.7 plus 166 into 0.3. You will calculate these 3 values, or जो भी maximum आएगा, that will be your answer. So I assume we have solved these 2 important problems. See, as far as I remember, we have almost solved 90% problems of UPSC. Why I say 90%? I think almost. I do not recall any problem which has not been solved. But again, yes, I do understand there are some problems for some subjective question. For numerical, there is no problem. Numerical, we have solved 100%. But some, let's say, subjective question from HRM, that, see, if I tell you some answer, I give you, okay, this is the model answer, that will not help you. in HRM, what I can do, I can give you, these theories, this conceptual block, and then you have to do the churning of your mind and then write the answer. For numerical set is fine. Let's say for HRIS, Human Resource Information System, I tell you 10 points. That will help you. Now you have to identify a way how to use those 10 points in your answer which you are going to write in UPSC. Fine. So now we will go back to our main agenda today. This is decision making. Here we will talk about, see what I will do, let's say you find a question in UPSC, question like, what happened? Just a minute. Let's say question on rationality. Now you can write a general answer. I assume you will take few points from this lecture, which you can use to write an answer for rationality. And let's say there are some keywords which are used in management book, like what is invariance, what is existence, what is uniqueness. So there is some meaning. Let's say not only in this quantitative part, even in OBHRM part, once the UPSC asked, what do you understand by stereotyping? This one simple question, you understand what is stereotyping. Let's say somebody says in society, woman name is, weakness. So that is a problem, right? So किसी को stereotype नहीं करना चाहिए. So what I am assuming after this lecture, you should be able, suppose you get a problem on, some problem, let's say on Prisoners Dilemma. I am of the view that someday UPSC will ask this question on Prisoners Dilemma. It is very much related to linear programming as well. And second thing, let's say you get some question on IESDS. Although I understand the chances are very less. In 2024, what is the chances you will get it? I will say not even 5%. But these thoughts, this lecture, this can help, this understanding can help you score more in even in paper 2 section A mainly. Paper 2 section A. If you use this thought, then I believe that should help you. Now, the question, the kind of numerical we are going to discuss, I will show you. Let's say what kind of question you can discuss. Okay. Now, let's say this question is there. Suppose this is a simple game, normal form game. There are two players. This is player 2. This is player 2, and this is player 1. And they are playing 3 strategies, L, C, R, and this is playing UMD, and these are their payoffs. Okay. Now they ask you which strategy will survive after IESDS. IESDS means iterated elimination of strategies, dominated strategies. Okay. So which strategy will survive? This kind of question you might get. Fine. So before we solve this question, we will build some theory. I will tell you what are games, and I am assuming that somewhere you will use these thoughts to do well in paper 2, right? So let's move to. Now somebody might ask why we need, let's say, why a game like Prisoner Dilemma came into someone's mind. Now you have to understand one thing. You remember we solved decision making problem, right? So what we were doing in decision making problem, let's say I started from this node. I went for, let's say, drill of oil, or what I will do, I will write it here. Let's say, I started from this point. I might go for drill, no drill, right? Then here I had natures, let's say some, maybe, let's say probability, some probability here, S dash, S plus, S minus, like that. So here what you were assuming, you were taking into consideration only yourself, right? Let's say rather than drilling for oil, this question is about how much you will score in UPSC. What is your success chance in UPSC or maybe any other test? So here decision making cannot be based only on your efforts, because it's a competition, right? A relative competition. So you will say, okay, I score, let's say somebody says I score 114 essay, okay, and other student is scoring let's say 148. Then we understand that 140 is a very, very wonderful score. But again, if somebody is scoring 148 and assuming all other scores are same, so this person will get better rank, or maybe this person might not even qualify. So this is the point. So what I'm trying to say, decision making should involve not only yourself but other players as well. This other player is the keyword why these games came into picture, because in decision tree and everything you were limited only to yourself. Okay, so this is what. Okay, so this is what they are saying. The drawback of decision tree suffers from one. The framework of decision tree suffers from one drawback. The world of decision problem was discussed as a world in which the outcomes that determine our well-being are consequences of our action, right? Only our action. We were not considering what other players were doing. So that is the problem, and that's why. Okay, so somebody might say, what we assumed. Let's say what I'm trying to say. Just a minute. The purpose of this example means the example which I've given related to a student's score, is to point out that our framework for a decision problem will be inadequate. Which our framework, the decision tree framework, would be inadequate if your outcomes and as a consequence your well-being will depend on the choices made by other decision makers. The example which I quote for for UPSC, your success will depend upon the hard work other aspirants are putting in. Fine. Then this is the important point. Perhaps you can treat other fellows as noise. What is noise in management? Error, right? For example, in regression, when you make a regression model, you say dependent variable y is equal to beta naught plus beta 1 x plus error, and you assume errors are are not correlated with uncorrelated, right? And so you can assume that the decision, the element of what you can assume. You can also assume that other players' effects might be taken as noise, but that is wrong. See, you cannot assume that your competitors are kind of an error, and if you keep the sample data large, that would not be a problem. No, see, errors would not be a problem when you apply the law of large numbers. We understand this in statistics. When there is a law of large number, then error is not a problem. But you cannot assume that your competitors are like a noise. No, that is see, this point is very, very important. Why I've invested again 2-3 minutes here. You have to think, okay, we already have decision tree, so why these games are required? So it looks like very simple, but as far as my understanding of linear programming and tools like this is concerned, this is a very deep thought. Okay, and not only this, just try to imagine this person. Let's say you see 3 chairs. Okay, do not call you do not call 3. You see, okay, chair 1. Okay, you see. Okay, I will say you see 3 impressions. This impression, this impression, this impression, and similarly you see this impression. So this idea that both of them is equal to 3. So now see, we know numbers, so we can easily count, okay, 1, 2, 3, 1, 2, 3. But the person who got this idea first time, that is very, very important. The same thought I believe is here when you are taken into consideration. other players' effects as well. Fine. Now, so what they are saying, static games of complete information are the most fundamental games or environment in which such strategies consideration can be analyzed. So first we will see what will be our process. First we will start with static games, in normal form games, right? Then maybe there are different kinds of strategies, dominant, dominated, mixed strategies. So what we are doing, we are building foundation. What is the two characteristics of a static games? First, they are played, we say they are simultaneous, every player, simultaneously and independently. See, it is the meaning of word here. You have to understand what is the word independently means here and simultaneously. Simultaneously means, let's say, two people are doing it. Okay, I give you a very, I will say rich example. Let's say there are two mathematicians, mathematician 1 and mathematician 2. They are working on some concept, let's say some concept from number theory. Okay, number theory. And they reach that conclusion at the same time, but without knowing each other's work, right? So that is what is called independently. Each player simultaneously and independently chooses an action. Okay. Second thing is, second thing of the characteristics of a static game is conditional on the player's choice of action, payoffs are distributed. Okay, you remember for a decision, if you recall the decision tree lecture, we said any decision thing will involve three things, A, O, P. A is what? Action, O is outcome, and P is preferences. So what they are trying to say, depending upon the choice of actions, whatever choice action you have chosen, for that there will be payoffs, and depending upon those payoffs, you will have preferences. Let's say you choose A, you get 10 rupees, you choose B, you get 20 rupees, so you will prefer B to A. That is what the concept is, very simple concept. Okay. So step 1 and 2 settle what is called static. Now there comes the what is complete information. So we said static games of complete information. Now this is tricky. Games of complete information, they require three things, four things. What is the first thing? All possible action. See, actually they use the term common knowledge. Now common knowledge is not so common. This is an important phrase. Common knowledge. Require that the following four components be common knowledge among all the players. What are the four important? All the possible actions of all the players. Let's say there are three players. So, okay, so there are three players. Sorry, let's say there are three players. So they know each other's actions. Fine, they know each other's action and all the possible outcomes. So they also know each other's outcomes and how each combination of each player affect which outcome. Let's say this player take this action. So how it will affect these two. So that will, as well as the preferences. The third part, this is the common knowledge among the players. This is very, very important. See, it is easy to say that, okay, so if you ask somebody, you might say, okay, this is general. Why these all assumptions are required? But this is not very general. These assumptions are not innocuous, right? Not, there are, a lot of theory has gone into discussing these assumptions. For example, let's say there are two persons, person A, person B. Person B is let's say outside on walking on road. The rain is there, so he will immediately see the rain is there. But let's say this person is sitting inside the room. He might not be aware of rain. So although that effect is there, but the information is not complete. So try to take these assumptions with a grain of salt. Now, generally, let's say, how do you define common knowledge? Common knowledge is if everyone knows E, right? An event is called common knowledge if everyone knows E, and everyone knows that everyone knows E and ad infinitum, and this means so on. So you got this, कि सबको पता है कि सब क्या क्या हो रहा है. So that is what common knowledge is, right? Now somebody might say, how it could be possible that everyone will know everything? Now, although we understand, this assumption is not easy to digest, but without this assumption, you cannot move into analysis. You cannot analyze games like Prisoner Dilemma and things like that. Okay. Now, there are some questions which I have discussed. I will suggest to go through them. Now there is another type of game, normal form games. What is its characteristics? It has three features. It has a set of player, set of actions of each player, and a set of payoff function. Again, that AOP thing, right? Now, a pure strategy. What do you mean by strategy? So let's say you have a strategy module as well. I will suggest you to add this definition in your strategy module. See, here what you are doing, you are to try to mix mathematical rigor with, let's say, what is BCG matrix, Ansoff matrix, your notes are ready. Somewhere put this thing, this definition in your notes and revise it 3-4 times. You will see automatically you will write somewhere in your mains answer sheet. A strategy is often defined as a plan of action intended to accomplish a specific goal, right? So simple definition, but you must write statements like this in a mains copy. Now let us move to pure strategy. What is pure strategy? A pure strategy is a deterministic plan of action, right? The simple definition is this: it is a player I, a deterministic plan of action. To the set of all pure strategies for player I is denoted by SI. This is some notation. SI, it denotes the set of all pure strategies. And generally, let's say this is the profile of a strategy. Strategy 1, strategy 2, strategy 3. What it means, let's say, somebody might say, I would like to prefer to go north, east, west, south, or other different directions. So these might be your strategies. Fine. Pure strategy means, the word pure here means you follow a certain plan of action, right? So these are some notation, no need to go into that. This is, okay, now my main point, the prisoner's dilemma. Generally, if you have heard about that question, what this question is, okay, here you can see the matrix. What it says, this says, let's say there are two prisoners, prisoner 1 and prisoner 2. Okay. They did some crime and now police caught them. Now they have two choices. Whether they can remain mum. Mum means silence, right? Or they can think, or they may confess. These are the two strategies for player 2. Similarly, there are two strategies for player 1, same mum or maintaining silence or confessing. Now, what is given in the question? If you maintain silence, what you will do? You will get a imprisonment for only 2 years. So we are denoting it by negative because imprisonment is a not a good thing. So that's why negative. So you generally you would like to have less imprisonment than more imprisonment. Fine. So minus two. That means 2 years in prison if both of them maintain silence. Okay. If one maintains silence, let's say player 1 is maintaining silence and player 2 confesses or thinks. So what will happen? Then the police will say, okay, see, player 1 you maintained silence, but player 2 confessed. So player 2 now will get only 1 year of imprisonment and you will get 5 years of imprisonment. Now you will be at, kind of, you will think, what I can do now? You will say, okay, let's say if I maintain silence, if both of us maintain silence, then it is fine. If I do not confess, and another player confessed, so I am going to be in trouble because I am going to be in 5 years in imprisonment. Now same thing will apply for, suppose you confess, and the player 2 maintains silence. See these numbers. Let's say this number, the left hand number indicates the payoff of player 1. And the right hand number indicates the payoff of player 2. Similarly, now see this, this quadrant. Here -1 is we will get 1 year of imprisonment if player 2 thinks. But if player 2 maintains silence, then player 2 is going to be in trouble for 5 years, right? And if both of them confess, then the police will say, okay, see, you might get up to 5 years, but if both of you confess, we will give you only 4 years of, imprisonment. Now, this is the important question. This is a very, very fundamental question in game theory, and this is my view. You must know it. So, generally, what happens? Not generally. We will say that its solution is they both will think. Both will confess. Both will confess means what both will say. They will say, okay, both will get 4 years on imprisonment. Now, what is the logic? Before we go into logic, we must understand that we make an assumption that both players are not cooperative. This is a non-cooperative game. This is very, very important. Let's say both of them are cooperative, then the solution will change. But their fundamental assumption is non-cooperative. So let's say you are a lawyer of player 1. What you will suggest player 1 to confess. Okay, so to confess, let's say you suggest player 1 to play strategy F. So player 1 will play this strategy. This means what player 1 can get? Player 1 can get either -1, yani 1 year in imprisonment, or 4 year in imprisonment. So I am assuming that you are lawyer of player 1. So lawyer of player 1 is suggesting player 1 to play Fink. Fink means confess. So then player 1 might say, okay, Mr. Lawyer, why are you suggesting me this? Do you think my friend is going to going to confess? No, he will maintain silence. So as a lawyer, you will say, okay, no problem. Even if whatever strategy your player the player 2 chooses, you will always be better off. This is the important point. See, think of it. Very, very important point here. What as a lawyer you are suggesting to your this player 1, that even whatever strategy player 2 chooses, you will always be better off. See why? Let's say, what is happening here? Let's say you chose Fink, you confessed. So, and let's say player 2 chooses mum. So, you confessed and player 2 chooses mum. So, how much player 2 will get? Player 2 will get 5 years in imprisonment. Okay. But rather than of confessing, if you would have chosen mum. So, how much you will get? You will get 2 years in imprisonment. See, if you maintain Fink, you do not, if you confess, you will get only 1 year in imprisonment. But if you confess, if you maintain silence, you will get 2 years in imprisonment. So here the lawyer's logic is correct. Similarly, here also we will say, if you confess, you will get only 4 years in imprisonment. But if you maintain mum, you will get 5 years in imprisonment. So irrespective of what the strategy player 2 is choosing, you are always better off confessing, right? This is the logic which the lawyer will give you to player 1, and lawyer will also tell that you have to assume that the players are non-cooperative, right? They cannot communicate with each other. So given this thing, now you can replicate. Let's say somebody is the lawyer of player 2, they will also say, okay, irrespective of whatever you try to choose Fink. So that's why the final solution comes this thing. Now somebody might observe the better solution is this. See, both of them are getting 4 years in imprisonment. But here, if both maintained silence, they might have got 2 years in prison. But see, that will become a solution only when the both players are cooperative, right? Now, one more thing, here also you must know a concept, Pareto optimality. See, you must use a concept like this in your mains copy, and in fact, I am not mistaken, UPSC asked once, write a short note on Pareto optimality, not recently. I can recall that, 10 years back. What the Pareto optimal solution means, let's say you have two choices. You have this choice, 2, 3, 4, right? And another choice is like this, 4, 3 into 30, this is 40. This is choice 1 and this is choice 2. So out of these, which is, this is Pareto optimal. Why it is Pareto optimal? That you have increased the payoff of 3 players. You have increased the payoff of player 3 from 4 to 40, 3 to 30 and 2 to 4. Yet, can you see what is happening in this? The difference between the 3 players have increased. Here only it was a difference of 1, right? Here, can you see the condition of player 1? He is getting only 4 rupees, others are getting. So, see why I am raising this point. Pareto optimality is important for games, but even in your GS part, let's say, Bentham's, right? Bentham's utility theorem, right? Bentham's utility. And you contrast it with John Rawls' social justice. John Rawls, John Rawls' theory of justice. UPSC in GS4 asked, I think it's 2016. What is your, they asked a question on the GS4 paper, you see, on theory of justice, some note. See, not only, here comes that philosophical view. What the Bentham assumed for utility. Bentham said this distribution of resources is fine, because he was looking for Pareto optimality. What Bentham said, Jeremy Bentham, you are increasing the pay of everyone in the society without making anyone worse. You are here also. What Bentham will say to player 1, you have gone rich from 2 to 4. Bentham is not worried about whether player 2 has gone from 3 to 30 and 4 to. So what is happening in this case? Inequality has risen. But John Rawls was against this. What the John Rawls said in the theory of justice, not only Pareto optimality, you also have to care for equity. That the last person, or if I can say that it is very much, this concept is very much related with the Antodaya of Gandhiji. Right? Antodaya of Gandhiji and John Rawls' theory of justice is not very different. So what my point is, when you study, so you might say this solution is, I'm calling it B. Let me call it B. This is B and A. B is Pareto optimal, when compared to A, but equity and equality is more in A. So it is up to the society which one they are going to choose. So, right. Now, here what you can do, this is another game. Let's say, let me tell you how to make games. There are 3 players, right? There are 2 players, player 1 and player 2, and they are playing 3 strategies, RPS. And what is given? R beats S, and P beats, S beats P, and P beats R. Now let's say you are looking for R and P. So player 1 is playing R and player 2 is playing P. So what is happening when there is a contest between R and P? Who will beat? P will beat R. So the player who played P will get one. The payoff is 1 if you win, and if you lose, the payoff is -1. So the left hand side you write the player 1 payoff, and the right hand side you write player 2 payoff similarly. Let's see this one. What is happening here? Player 1 is playing S, and player 2 is playing P. Player 2 is playing S and P. Okay. S and P. So S beats P, right? S will beat P. So player 1 will get 1 and the player 2 will get -2. So this way you can make the kind of generally people say this is matrix, but you have to be cautious. See, generally how you write matrix. Matrix is nothing but vectors. Let's say I've written a matrix 3, 2, 1, 7, 8, 9, 11, 0, 15. This is a matrix. So this is also kind of a matrix, but can you see? See, this is player 1 matrix, right? This is player 1 matrix, and this is player 2. Okay. So this is player 2 payoff, right? This is player 2 payoff. So you have to visualize like this. You can call it matrix, but the right word is to call it bimatrix. Bimatrix. Fine. Now, okay, this see why I'm discussing these kind of games. These are the very famous games. Somewhere UPSC might mention it, in some maybe through OM problem or QAM problem. If you will get matrix, you will get matrices like this. That I want to assure you. Now, this is again very famous game. It is called Battle of Sexes. What it says, see, it's a very simple matrix and a simple game, but the thought is very, very deep. What it says, there are two players, Alex and Chris, and they want to meet each other, and they prefer meeting to no meeting, and they have to, but A prefer opera to football. So A might have two strategies, whether to go opera or to go football. Similarly, Chris prefer football to opera. Okay, so this is their preferences. Now they have to decide where to meet, and there is no communication and all those things. So let's say this is the bimatrix given. Let's say if both, let's say Alex chooses football and Chris chooses opera, so they are not going to meet. So the payoff for both will be 0-0. Let's say Alex chooses opera and Chris chooses opera also. So we were told that the opera is the Alex prefer opera. So the payoff of Alex would be more, that would be 2, and the payoff of Chris would be less, that would be 1. Right? But still, still they are meeting. It is better than not meeting at all. So it is more than 0, but it is not equal to 2. Similarly, you understand why this is 0. Here, what will happen? Chris will get more payoff because Chris prefer football, but Alex prefer opera. So both are, if both choose FF, then the this will be the payoff. Now, why this is important? Why this game is important and how it comes into picture, that we will tell after 5-10 minutes. But before that, what I will do, I want to show you. Okay, now these things you must understand. Let's say you are writing things in your answer sheet. You want to explain what is rational, what is intelligent, what is common knowledge. So do not write a loose statement there. Try to write, how good books write about rationality. So when you say somebody is rational, see, in OB also you read what is economic man, rational man, right? Organizational theories are there. From the perspective of operation management, what you can see, the players are rational if they try to maximize their payoff. And everyone, when you observe it, everyone is trying to do that. Everyone wants to maximize their payoff, right? Consistent with his or her beliefs. Okay, what is belief, that we will discuss later, but you get the idea. What is rationality means? Trying to maximize your payoff according to your belief. Intelligent, right? A person who is intelligent knows everything about the game. And what is the three things? Action, AOP, right? Action, outcome, and preferences. You know the three things. Then you will call that person. See, generally what we say, person is rational. We confuse rationality with intelligent, but you must have sharp distinction. Rationality means you are trying to maximize your payoff consistent with your belief. Intelligent means you know everything about the game. That is common knowledge, right? We saw just 5-10 minutes before. Common knowledge is the fact that players are rational and intelligent. When take union of both, that become common knowledge. And self-enforcement is, see, just now we discussed prisoner dilemma game. So we saw what was the solution at FF, right? FF was this was the solution, -4. Now this solution is self-enforcing. Self-enforcing means if you leave these two players at their own and they are non-cooperative, then you are going to get this solution. That is the meaning of self-enforcement. Fine. Okay. Now this is fine. Okay, now 3 more words you must know. Let's say, okay, see, what is the meaning of solution concept? Now you have given that strategy. Okay, you were given the Prisoners Dilemma game, so you decided how you are going to identify a strategy. So what was your strategy? You are going to minimize your risk. That was your strategy. So, and that become your solution concept. But to define a solution concept, you must know 3 things: existence, uniqueness, and invariance. Now, you see, these 3 concepts are very much related to your inventory control as well. In OM, I will tell you, in OM you study economic order quantity, period order quantity. You say that economic order quantity model has to be robust. When you say what is the meaning of robust, that I will explain what is. So here, what is the meaning of existence? Existence means that solution must exist. That particular there should be number of strategies. Existence, how often does it apply? A solution concept is existence if it applies to a wide varieties of games. WIDE, wide. If it is applicable to a wide variety of games, then it is called existence. Uniqueness means, see, uniqueness and existence have trade-off. Let's say uniqueness means, see, you are trying to find something unique. So you have to strike a balance between existence and uniqueness. Let's say something is unique, then how it could be, prevailing everywhere. So, and if you say, your solution concept is like that, it is prevailing anywhere, that is of no use because you are looking for a particular solution. So that balance you have to strike between uniqueness and existence. The third is invariance. Invariance means, let's say, in linear programming you study sensitivity analysis. Let's say your objective function is this. Let's say this is your objective function. Profit, just a minute, what happened? Yeah. You are trying to maximize your objective function, and this is like 2x1 plus 3x2. Okay. So, and what you will say, if I change this coefficient, how my solution will change? Whether my solution will change. Let's say rather than 2, if I take 2.1 and here I take 2.99. If your solution is changing, then this solution is not robust. That is what they are saying. Invariance, how sensitive it is to small changes. Okay. So generally in technical language you say epsilon. This is epsilon, right? Small changes. In calculus also you must have understood, right? Reanalysis का कोर्स जिन्होंने भी किया है. If you are non-engineer, don't worry. इसमें यानी कुछ का जरूरत भी नहीं जानने का. For management optional, but I thought I will just share it with you. Now, this is important. Now, see, somebody says socially undesirable. Even आपकी Robbins book में और HRM में भी, they have written phrases like this. See, when you find in management book concept written like socially undesirable, there is a meaning of that, and you have to study that rigorously. What it says. An outcome is considered to be socially undesirable if there is a different outcome that would make some people better off without harming anyone else. So you got it, what it is, the solution which is Pareto optimal. No, see, if everyone had 2 rupees, 2, 3, 4 rupees, right? 3 people having 2, 3, 4 rupees. Now in another situation, somebody having these 3. So this is Pareto optimal. Because the good of the society has increased from 2 to 3, 2 to, it has gone to 3, 3 to 30. But here, again, the critics of this definition will say, Pareto optimality does not take into consideration equity, right? That is a big critic of the definition. Now this is some notation. Just leave it. Okay, what I will do, I will go directly now to a game. Okay. I want to discuss one game so that you understand rationality of common knowledge. You can leave it, right? Okay. Now, once you must know what is dominated strategy, and okay, let's see this one. we just saw that players are rational, they are intelligent, they have common knowledge, and so what it means. So a rational player will never play a dominated strategy. You know, if let's say player 1 can get these payoffs, left hand side, and player 2 can get these, right? So you have to look for, let us try to identify if there is a dominated strategy here. Let's say for player 1 we see, player 1 if player 1 play L, sorry, player 2 play the L, okay, just a minute, we are calling it player 2, no problem. If player 2 plays L, so what will the payoff? 6, 2 and 0. So here 8, 4, okay, 8, 4 and 1, right? It is dominating first one, right? Completely. Can you see? 1 is greater than 0, 4 is greater than 2, okay, this is fine. Then, so what about this one? But M is not dominating H because 8 is greater than 4, 4 is greater than 3, but 1 is not greater than 2. So what you can see, and what about this one? Similarly, L is not dominating H strategy, right? So if given a choice between L and M, you know you are going to play M strategy. Okay, now you have analyzed for player 2. Now let us see for player 1. What is happening here? 6, I will just remove it. Okay. Let's say 6, 2, 0. It is being dominated by this player. 8, 4, 1. Yes, you can see. 8, 4, 8 is greater than 6, 4 is greater than 2 and 1 is greater than 0. Right? What about this one? 4, 3, 2. Here it is, see, here it is not dominating. Right? So what you will say, the strategy which are dominated, they are never played. Right? So I think in this case you will not play this one, right? And in the earlier case you will not play this one, right? So this is what I want to share. You know, what is the dominated strategy. So okay, I think they have also written L is a dominated strategy for both players. So L was dominated here and this player as well. So what you will do, you will just eliminate L from player 2 and this one. So you are left with only this one. Here what you will see, do you find any dominated strategy? Let's say, however, neither, okay. So, you know, this is what they are trying to say, you will eliminate the dominated strategy. Okay, fine. Okay. Right. Now, what I will, to wind up, what I will do, I would like you to go through one numerical. Just a minute. Yes. What you do, you please, read this iterated elimination of strategy dominated pure strategies. I will just show you. Okay. See what is the what it may, when you observe, this is a game, right? This is player 1, this is player 2. They can have 3 strategies, L, C, R, and U. When you observe, there is no strict dominant strategy for. So let's say 4, 2, 3. It is not being dominated by 5, 8. Sorry. Just a minute. Okay. Let's say 4, 5, 6. It is not dominating 2, 8, 3, or neither it is dominating 9, 6, 2. And similarly, you will check for these strategies for player 2. 3, 1, 0. 3, 1, 0 is not being dominated by 1, 4, 6. But here you will observe R is dominating C strategy, right, of player 2. So what player 2 will do? Player 2 will not play strategy C. So this is gone. Now what you are left with? You are left with only this game. So I will show you what you are left with. After eliminating, you are left with these two games. Okay. Now from here, just a minute. Now what you will see, 4 and 6. 4 and 6 is dominating M and both things, right? So player 1 will never play M and D when compared to U. So these games will never be played. So now finally you are left with only these two strategy, and out of these two, what the player 2 will choose. See, now the player 1 have only one strategy, U, but player 2 will choose either among R on L, wherever he is getting more payoff, he is getting more payoff at 3. So that you will choose what strategy? This one, 4, 3. This is the concept, this is the important thing. See, this concept is very much related to your assignment problem. There also you do, step by step elimination. Here also you are doing iterated elimination of this is called IESD, iterated elimination of strictly dominated pure strategy. So whatever strategy which is being dominated, you are going to eliminate. So it might happen in the first iteration, you find only one dominated strategy. But when you eliminate those particular strategy in another iteration, you might, in the reduced game, you will find more dominated strategy, and those you can reduce. And this is the way you reach your final solution. So remaining part, I will, you can take this numerical and try to solve it. You will find the solution here. And I expect if you get a question like this in UPSC, you should be able to solve. Thank you very much.